I'm Dr. Ivo N, and my message for you is, it's all about flow. I like fluid mechanics, so go ahead, call me a nerd, but my flow's got power proportional to its velocity to the third. What this means is that I like and study flows like air flows and water flows, and that you can get as much as 8 times more power from a wind turbine if you just double the wind speed. Or if you triple the wind speed, you can get almost 30 times more power. But flows are important not just for power generation like wind, hydro, solar, geothermal, nuclear. We can also improve the efficiency and performance of all kinds of vehicles like cars, trucks, ships, submarines, jets, drones, and even land a rover on Mars. Even making diapers can be improved by improving flows. True story. Flows are everywhere and they are important. And if you're not convinced, try to stop breathing for 3 minutes. And yes, flows and studying them will help us decrease the spread of COVID-19. As a matter of fact, I was going to invite a friend of mine to demonstrate the importance of flows in flight, Batman, but his mask doesn't cover his nose and mouth properly, so we're socially distancing. Now, how do we study flows? We can use theory and equations just like the one I shared with you, but the problem is the type of equations that completely determine the flow, partial differential equations, are difficult and oftentimes impossible to solve by humans. Nevertheless, when it comes to flows, I have complete domination because I got my back covered by these partial differential equations. We can solve a modified version of these equations using computers, and this is called CFD, Computational, or some people say colorful fluid dynamics. This, for example, is a simulation done by a student of mine looking at how COVID would spread in a room. But even with computers, we're not able to solve these equations, and we need to simplify and approximate the equations, and in doing so we lose accuracy. And while we can see everything in a simulation, we often do experiments to confirm our results. My favorite experimental technique is called particle image velocimetry. It's like watching the snowstorm that's happening outside right now. I can determine how strong the wind is by looking at how far a snowflake travels in 1 second. The more distance it travels in 1 second, the stronger the wind is. Now, when we do the experiments, we use cameras to capture these images, and to increase the accuracy, they should not be very blurry. To avoid that, we shine a laser light in pulses, just like in a dance club where you can see people frozen in time. But our lasers are much more powerful, so we need to have protection. That also looks cool. So, theory, computations, and experiments all complement each other and help us better understand and improve flows. And remember, it's all about flow. Hey Batman, what's up, bud? You got COVID? I told you should wear a different mask. Hold on for a second. To learn more about flows, check out my rap video, It's All About Flow, produced by the American Society of Mechanical Engineers. Yeah, I got you, bud. I'll take care of the bats. I'll feed them. Yeah, no problem. Yeah, no worries.